Before we learned about the comparing two groups when we have a dichotomous variable for a continuous variable. But what if we have more than two groups? For example, in this example, we have three groups and we are checking the blood sugar as the continuous variable that we have, and we want to compare it. In this case, we can say that the null hypothesis will be there is no significant difference for the mean of the blood sugar between these three groups. Uh, and then if we want to test this hypothesis, we need a p-value, and in this case we are using the one-way analysis of variance, or Anova, which is used to determine whether there are any statistical significant difference between the means of two or more independent unrelated groups. As I said, two or more. Also, we can use it for two, although you tend to only see it used when there are a minimum of three rather than two groups. So we go for the more than two groups in this case. And also the other tests as non-parametrical that go in this category, we have Kroskal-Wallis Edge test. Can put an edge here also. And it's also sometimes called the one-way Anova of ranks, and is a ranked-based non-parametric test that can be used to determine if there are statistically significant difference between more than two groups of an independent variable and a continuous or ordinal dependent variable in this case. So I put this edge correctly. There are another test also that we may use as known as Friedman test, and the Friedman test is a also non-parametrical alternative for one-way Anova with repeated measures. It's used to test for difference between groups when the dependent variable being measured in ordinal form. So the p-value from the test that we have here, it's just tell us that there is a significant difference somewhere between these groups or not, but it doesn't give us that this difference between A and B, A and C, or B and C. And we need to do another test known as the post hoc to answer this question. There is an exercise here for variable evaluation of the lecture, and we want to see if there are any difference regarding the fear of the statistic in the first day. So we have a categorical variable, evaluation of the lectures, which has three levels, and then we have the continuous variable as fear of a statistic that we want to compare between these three groups. So we use one-way Anova. Let's look at the assumptions that we need to know about this one. The first assumption is we have one dependent variable that measured in continuous level. Okay, check it, and then we have it. One independent variable that consists three or more categorical independent groups. Okay, we have this one as the evaluation of the lecture. I will show the subcategories, and you should have also independence of observation. It means that if there are these three different groups, someone can answer for evaluation only one option. It's not some we are not sharing people in the different the answers or different groups in the categorical variable. And there should be no significant outliers again that we can check in the groups in your independent variable. And also your dependent variable should be approximately normally distributed for each group of independent variable. So we need to check the test the normality here also, and you have homogeneity of variance. Homogeneity of variance. It means the variance is equal in each group for your independent variable, and we will explain them a little bit more later. To do this one, the first step that we want to do a Anova is to go analysis, descriptive statistic, and explore, and then we can put the dependent in the dependent list the continuous variable, as you see here, fear of a statistic, and in the factor, the evaluation of the lecture that has 3 levels in this example. And then we will get, like before, you are going to have the plots, of course, and use the options. And then here we are getting the box plots. If we have any outlier, we can see it here. That in this case, we don't have any outlier. This example about the analysis, descriptive, and explore is explained in the independent t-test video. So if you want to know better about this and how you read it and how you do it in details, you can look at the other video. And also we look at the test of normality against Shapiro-Wilk test, and if there is nothing significant, as you have no significant here, we are thumbs up and say that there is no violation in the for the assumption of normality. So we accept it, and then we can continue to the next step. In this case, what we do, again, we are comparing means, but here we comparing means one-way ANOVA here. So it's go analyze and compare means and one-way ANOVA. It's straightforward in the SPSS, you can find it. And here we need to put the dependent in the dependent list our dependent variable or continuous one, fear of a statistic in the factor, the categorization that we had, evaluation of lectures. And also then we need to go to the to post hoc and just show you one more time in the previous one. So we have post hoc here, and if we just go in the post hoc, then we are choosing the 2 key as one of the methods for the post hoc. As I said, post hoc tell us that the difference will be between which 2 groups if it exists. So also we can go and to the options and use the options as descriptive. We are going also to see the assumptions as homogeneity of the variance test. We should look at this one of the important assumptions. We also at the same time choose 2 other tests known as Brown-Forsyth and the Welch. We use these tests if in case we didn't have the homogeneity of the variance. So if we didn't reach this assumption, we go for the Brown-Forsyth and Welch instead, actually the one-way ANOVA. So in this case we are that's easier to have all of them in this part and look at them. If you just click on the OK, then we have the test of the first thing that you are looking is the assumption that we have about the homogeneity of the variance. As you see here, we have a non-significant value. If it's non-significant, then we are doing the thumbs up and say that's okay. So the homogeneity exists, and then we don't need to do something else. We go directly to the ANOVA, and in the ANOVA we are looking at the level of significance, which here it shows that there is no significant difference between the group A, B, C, which back here to the null hypothesis for variable evaluation of the lecture. Is there any difference regarding fear of statistics? Nullist hypothesis says there is no difference statistically significant between these groups, so we accept the null hypothesis when there is no level of significance here. So we don't need actually to look at the post hoc test when there is nothing significant, but just here as an example, you can see that there are 3 levels for this categorical question, that bad, good, and excellent. And here we have 3 parts. First, we compare bad with good and excellent. So bad and good and bad, they are just in the opposite direction, measured again here, comparing good with bad and excellent, excellent with bad and good. And if you look at the values, for example, between bad and good, here your level of significance is 0.695, and if you look at the between the good and bad, also it's the same value. But if we look at the mean difference, we can see that here we have a minus, and you have here is the plus for these values. You have the repeated values in many other parts also, as you can see here. But as I said, we look at the post hoc test only if the ANOVA is significant. We are looking at this one, and then we can find where the problem is. But imagine just we imagine that what if the test of homogeneity of variance was significant? Then there is we cannot accept it. Then we don't have the homogeneity. We cannot use the ANOVA. And in this case, we need to use the other test, Welch and Brown Forsyth. The Brown and Forsyth test is test of equal population variance. It's a robust test based on the absolute difference within the groups from the group median, and it's a suitable alternative to the other tests that we are doing here.